Seaweed, one of the oldest living creatures on Earth, is an inexhaustible and renewable resource, widely distributed in the oceans. Alginate fiber is a new functional bio-based fiber material, with seaweed extracted from algae as a raw material. The process of producing alginate fibers includes the extraction of sodium alginate powder, the raw material for spinning, and the forming of the fibers by wet spinning. The fibers are intrinsically flame retardant, antibacterial, anti-mold, and comfortable for natural functions. They are also hemostatic, moisturizing, and biodegradable, all of which are unparalleled advantages over traditional fibers. In 1944, the first patent for alginate fiber was applied for in the UK. Since then, the research and application of alginate fibers in other countries has been limited to the manufacture of medical non-woven products in small scale. They have not been able to solve the problem of alginate fibers dissolving rapidly when they meet salt water or detergent, failing to realize the application in the textile field. We have researched and developed alginate fibers since 2004 to achieve a wide range of applications for alginate fibers in the textile field. We have achieved the washing fastness of those fibers, a 20-fold increase in fiber production efficiency, and a 50% increase in fiber strength, eliminated the use of dewatering agents, and developed dyed and colored alginate fibers. We have built the world's only automated production line for alginate fibers for textiles, with an annual capacity of 5,000 tons. The technological breakthroughs have made the application of alginate fibers in textile and clothing fields a reality. Compared to regenerated cellulose fibers, including viscose and lyocell fibers, the production and application of alginate fibers for textiles spend less water and energy with no need for strong acids, alkalis, and organic reagents such as NMMO. This is a unique advantage of alginate fibers as a bio-based material. The first source of traditional fibers is natural fibers such as cotton, linen, wool, and silk, and regenerated plant and animal fibers that depend on the land to grow. The second source is synthetic fibers from petroleum. Both the two have been severely affected by the lack of land resources and oil resources for many years. The development of fiber materials from abundant and renewable seaweed resources can achieve effective conservation of plants in arable land, clean production, and environmental protection. Compared to traditional viscose fibers, alginate fibers use 100% less of sulfuric acid and sodium hydroxide, 100% less of toxic gases such as hydrogen sulfide, and 80% less of water to produce 1 ton of fiber. Also, relying on the coagulation bath cycle and material recycle technology we have basically achieved a 100% reduction in the production of wastewater and solid waste. At the same time, the use of water as a solvent has eliminated the use of large amounts of organic solvents. Reduced carbon emissions. Compared to lyocell fibers, alginate fibers do not need the use and recycling of organic solvents such as NMMO. So alginate fibers reduce carbon emissions by 50% and energy consumption over 60% compared to lyocell fibers. The functionality of bio-based fibers, without adding any flame retardant, antibacterial, or anti-mold reagents. Alginate fibers have a limiting oxygen index of more than 55%, a bacterial stasis rate of more than 99%, and a mold resistance rating of the highest level 0. Such inherent flame retardant, antibacterial, and anti-mold properties are not available in land-based cellulose fibers. The development of alginate fiber technology has achieved more than 50 Chinese invention patents. Patents for salt detergent-resistant alginate fiber production methods have been granted by PCT in more than 20 countries, including the US, Japan, Korea, and Europe. Such kind of research and development has won a number of major awards including the first prize for scientific and technological progress awarded by the China National Textile and Apparel Council. In addition, we have made a number of national and industry standards. In the future, alginate fibers are expected to be promoted in a number of fields such as clothing, medical, nursing, and transportation applications. We will continue to search for a third source of fiber from the sea through continuous technological advancement, providing the global textile industry with new low-carbon, environmentally friendly, natural, and multifunctional fiber materials.